quick stream on constructors and destructors and just like plain old data. So like what we're used to, if you like a program, usually if you don't program in C, you might be used to having your resources collected in some way, either by garbage collection or or by RAI. Do you say that? Like, is that the way it's pronounced? By the way, anyway, it's like in C++, right? So and once you have constructors and destructors, a language, a language really changes. So I think I have some C markup here in this. Here it's anyway. So if you think about, you have some data, like you have the struct foo, and you have something, you might even have a file handle like that, and you have your program is doing something, right? And so if this is C, then you don't have any behavior. So you might might just have a foo here, and right now it's not initialized. Maybe you put in some data, you might open a file, put the data in there, something, and then you do your stuff, and then you have to close that, like that, right? Really explicit and stuff, but and that's sort of wordy. So maybe you wanted to add something like, if you have C++ and you think like, okay, right, I have foo here, and so if I have a foo, then I do a foo close, right? Something like that. And then of course I need to, because I'm assuming that, then I also need to, when I do the foo, when I construct that, I need to make sure that this is null, right? Something like that, and it's like not completely C++ and not completely C. And suddenly, I have the foo here, maybe I initialize it like that, and I do this, and suddenly it's just going to magically work, right? Like that. So isn't that good? You just sort of you reduced what you had, right? But there's a problem with this. So let's say you have something else. You have your bar, whatever it is, and then you have some other resource. So you have a resource handle that you get somewhere, or a resource. You have an ID. Okay, we have an ID, right? And then we have. So what you want to do is just like you create a bar somewhere. So you get a bar, get bar, and then when you when you delete the bar, it's going to release whatever things you gave it. So you have some resources. Yeah, let me have like a resource provider p, okay, and I give it to bar. That means like inside of bar, it's like doing something. Okay, it's assigning the ID to bar. Okay, so we have a ID, and we do something like sorry about this, it looks really ugly, but you're gonna get to the point here. So you have a bar, and then you want to destroy that, but how do you do that? You just have the ID. So maybe you need, like, you just don't just need this ID, you also need the resource provider. So now you have this, and you have the P, and I would never use just P like that, but this is a very meaningless name. So now you have like, okay, it's a P and you do like free ID, right? Good or bad? It might be bad because what you did right now is you introduced this hidden dependency on the resource provider that you have, right? So here you don't see that you have a resource provider. Where is it? Okay, you have it here, but how do you know that it's actually retained here? You don't need that. Know that. It's just something, right? And then you delete it here, then you're actually invoking resource provider. And if you have programmed in C++ to any extent, you know that this might break. Like eventually you'll have some code like this and like P is not there. It's gone, it's been reclaimed, whatever. Or you do this free, like at a time when the resource provider isn't prepared to get this, right? Because you have all these implicit things happening. And what that means is suddenly you have connections. What if you have like 1,000 bar things and then you delete them in various ways? And then you have something, when you delete something or in the middle of that you are doing something to the resource provider. There is a connection here. You might have something like when you free this, you're actually doing something inside the resource provider that in turn deletes some objects and they in turn affect something else. So you have this sort of intricate web of things, and if you do something like you're registering something here in somewhere in some object and then you're processing events, then you know that you can get really funky stuff happening when you're deleting things concurrently. And that's like the typical thing there is seeing Java questions on Stack Overflow about Java and like, oh, I have this concurrent modification exception because they are not doing the modification in their loop, but they are looping through something and then they want to delete some object in the middle of this, but then that loop in turn is using something else that's so eventually they are concurrently modifying their stuff while they are iterating over it, and then you just like patch it by, okay, let's put the objects in a list before I iterate over it, and then I can remove it while I go along. But then you can do that, like then you can get to the next level of breaking things that way, because maybe something else depends on it. And you might, okay, you want to send something, you are having something and you're deleting that from the list, but then whatever you're doing before that would send a message to that object that you just deleted from your list. And it expects that, when it gets that message, then it should delete something, but it's no longer in the list, so that thing doesn't get deleted or whatever happens. So there are very funny things that can happen when you do like this. So because you have a lot of implicit code. But okay, so the implicit code is one thing. But you also have the fact that suddenly you really need to make sure that you are, that you are aware of the integrity of bar, right? Because you can't, if you get like bar when it's half created, like if you leak bar here, like do some do call with this, there are some things in C++ that like sort of makes this hard, but it's definitely possible in Java to do that. Suddenly you have like this incomplete, and you can get that in C++ as well, like doing other stuff, but you get this incomplete thing that you can only be sure works when it's like complete and you're doing stuff to that. And then you have the thing where you want to maybe bulk allocate something. So you want to make like 3 bars, right? You want to make have an array of bar that you want to do. But or if you do that, maybe you want to like, okay, you have an array of bar, you want to do like, okay, like just in C, you would just, you know, malloc this, like take that times 3, I want 3 of these, and then we're done. That's almost done, and then you iterate over those and like initialize them to the value you want, like maybe you do for int something like this, and then you do init bar with that particular bar. Okay, and they are initialized. Yeah, this is fine. When you do this in C++, you have to do the placement. I never do that, but you have to invoke the constructor in a special way to get that. And similarly, if you want to destroy everything, you must invoke the destructor. Yeah. So that okay, that of course you have to invoke that, but that's basically something. Suddenly, you also have the responsibility to destroy things, right? And even though it was originally we saved code, right? Because we just did this and it would automatically return stuff for us. But now, what if I do like this? I have, like, if you consider this thing I had, right? If this was now C, I would just do this to remove all the bars, right? But okay, there is an array free in C++, but the point is that what if I don't free it? Okay, maybe I don't even free it. I just want to write something else. I want to use that memory for something else. Like maybe there's just a buffer. So I have a buffer of memory. So I do malloc something big, and then I say, okay, let's just make this bar, right? I take this part, and I want to take, I take the buffer, and then I want to use this as a bar, and then I run around with doing stuff like that on this. Okay, so this is now obviously not right. I should do this. But anyway, so it should be like, okay, maybe I like that, whatever. The point is that when I want to do something else, I want to maybe use that for my baz here. So I can just take that buffer and then do the same thing, but with my baz. I don't need to think about the memory. And this is the implication if you have like a temporary allocator. Like Odin has a temporary allocator, which is a ring buffer, so you basically just overwrite the memory. But you can't do that. And then that way, like in C or in Odin, you don't need to worry about the memory, right? Because you just eventually you all write whatever you used, right? And similarly, when you do a buffer, right? In C, you would like do something like can have a static buffer like this, like okay, I have this buffer here, a buffer, and I don't care here. I can actually make that static. It just stays there, and I don't care about if it's like used up before, or like been used or scribbled to. It doesn't matter. I can just use it whenever I feel like it, right? This is a pretty bad idea for multi-threading, but just bear with me. It's like you don't care about the memory after you use the memory, just whatever. If it goes boom, it doesn't matter. But for C++, suddenly you need to make sure that this is actually running through a delete, right? Because you might have things that are dependent on that you actually took the old data and destroyed it in the right way. And what happens if you forgot about, like you had some data and you thought you initialized it and then you destroyed it? Now you're doomed. If it's like, it will crash, right? So you gain some more responsibilities. Like with C, it's like you have these when you have some data, that's just you have something written on paper or whatever. It's like, okay, you don't need it anymore, you can throw it away or whatever, right? If you lose it, maybe you want to recycle your paper, but you don't care if you like recycle it with, you don't need to take care of it. But like an object that has a constructor and destructor, it's more like a baby. You have to take care of it all the time, right? Well, maybe you don't destroy your baby, but okay, but something you have to take care of it, right? You have to make sure that it's like just goes through this life cycle. And just because when you destroy it, it will do some things for you, right? But you have to do something for it. And that whatever it does, it's also implicit. So what I mean is basically there's a trade-off. If your data is not alive in any way, it's like it just lies there, you can scribble on it, whatever, and then you can just clear it and use it again, whatever it is, doesn't matter. It's not like alive or has any integrity, except what you impose on it. Like, oh, I know I wrote to that, so it should be okay. But there is nothing, like it doesn't have anything to maintain its integrity. So there are good things about that and bad things about that. Obviously, you would like to have some integrity in your data, right? But you have to impose it from outside. You have to guarantee that you're not doing anything bad to it. But that also means that if you know what you're doing, you don't have to, bother with the, maintaining the integrity when you know it's not important. But for C++ or Java or something, it's crucial that you actually not Java, since it rarely has this destructor doing resource deallocation, but the problem is similar anyway, because you are suddenly responsible to make sure that this object that you're handling is being destroyed somewhere. Like some function needs to, the alloc thing needs to happen in a certain way. Not just in any way what you feel like, it's a certain way, or you will lose this integrity that you built up, which is super important, because if you don't follow these rules, it's like getting, Gizmo for your birthday present, and then you forget all the rules, and then you have gremlins. That is bugs in your program, right? So that is, so there is the trade-off. So if you have, what I'm saying is more like, if you do have constructors and destructors, you need to use them so you get maximum benefit from having them. Just having them just because it will seem convenient is bad, because then you are locking yourself into quite a bit of extra work. But if you use it well, that can be beneficial. So you need to have like the downsides of it outweigh the good parts have to outweigh the maintenance that you need to have to make it work well. So you need to take care of the problems, but the problems should not be bigger than the benefits. And if you go for the other approach, where you have like data is just data, and you impose structure on this data by yourself, then you should also use that. So you should use like temporal allocation and pushing data down, like you can just allocate it somewhere, and you know that you can just give it somewhere and you automatically reclaim that memory. You can reuse the memory and stuff like that. Use the fact that you're imposing order and structure on your data and no one else. So you have that full control. That is something you should also like try to maintain. Either you have one or the other, but not try to do sort of constructors, but maybe not constructors, or halfway there, and you get like the problems with both. So you can't, maybe you have like, it would be nice to have C, but you have a constructor, right? Like setting the value of something to true by default. Okay, so this value is true. That's neat. but that suddenly means that you have to run the constructor everywhere. Now you're not free anymore. Suddenly, sometimes the constructors run, sometimes it has the default value, sometimes it doesn't. Well, that's super bad. So one way of using the clean, and you have no the C way is actually have 0 being the default value that makes sense. So people have talked about this, like using series init, and that's a really good principle to use for C, because then you you will automatically construct your things just by doing calloc or memset. So that sort of ends what I wanted to say about that. I've written a bit about it, but I just I had a discussion on Discord, and I just wanted to say something about it again. Okay, thanks for watching.